assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Okay, a conjugate acid-base pair is a pair of an acid and a base on the products and reactant side of a reaction that applies to our Bronsted-Lowry definition. So if we take a look, let's just look at a pretty classic example. We have NH3, which is ammonia. That's a base. If we put that into water, we will see how it reacts. Now it is a weak base, so we use that double arrow. Okay. So since ammonia is a base and water is a conjugate, or I'm sorry, water is the acid in this case, we'll see a hydrogen ion transfer. It'll leave the acid and go to the base. Okay, so the acid always loses a hydrogen ion, the base always accepts a hydrogen ion. Right? So on the other side, our products then will be NH4 plus, the ammonium ion, because it's the acidic form of the ammonia, and we'll be left with hydroxide as our base. Okay. So when we label these, right, the base accepts the hydrogen to give it the acidic form, so that ammonium ion is our acidic form, so we call that the conjugate acid. And the water has lost or given up its hydrogen, so that is now in its basic form of hydroxide, so that is the conjugate base. Okay. So a conjugate acid-base pair, okay, we actually have two in this reaction. So one pair would be the ammonia, which is the base, and the ammonium ion, which is the conjugate acid. And the other pair would be the water, which is an acid, with its hydroxide, which is the conjugate base. Okay, so you'll always see the acid and base on the reactant side, the conjugate acid and conjugate base as the products. And you can identify them by looking at whether the molecule has gained or lost a hydrogen ion.